So I am chatting here with Professor Douw Steyn from the University of British Columbia's Atmospheric and Environmental Sciences. He's going to have a lot of interesting stuff to say around what's been changing in our environment lately during this global crisis. How we've seen a lot of graphs and charts that have shown how pollution, particularly in Wuhan, has just gone way down from, for example, a year ago. I was curious, is this also happening here in Vancouver? From what you've read?
Absolutely, it's happening in Vancouver, and the entire story is driven by, effectively a shutdown of our economy. The economy has gone into medically induced coma.
Yeah.
And what that means is that people are doing less of just about everything they did, but most particularly, we're doing less of traveling. So any consequence of the transportation sector is dramatically induced. And one of the consequences of the transportation sector is we move stuff around by burning fossil fuels. And the consequence of that burning is we emit all kinds of substances into the atmosphere. Scandalous, but we do. The consequence of that emission are broadly in two categories. One is the continued increase of carbon dioxide in the atmosphere, which results in global warming. And the other one is the emissions cause local air pollution, which whose consequence is declining human health and increasing human mortality. Very simple.
Yeah.
And now, as things are being shut down, less of that is happening. So there is a reduction in the total amount of carbon dioxide emitted into the atmosphere, both locally and globally. And there's an improvement in air quality, and that air quality improvement is documented all over the place. There are these famous maps from China showing nitrogen dioxide. Your watchers may want to be clear about what this is. They usually call it mean tropospheric nitrogen dioxide density, and that means the concentration of nitrogen dioxide in the lower parts of the atmosphere. And they usually take averages over chunks of time, particularly there's sort of January before the shutdown and February after the shutdown. And you can see a reduction in the level of tropospheric nitrogen dioxide. Nitrogen dioxide is complicated because it's a respiratory irritant. People with any pre-existing respiratory conditions will suffer quite severe symptoms, including death from nitrogen dioxide in the atmosphere. Nitrogen dioxide is caused because we burn fossil fuels in the atmosphere, which contains nitrogen and oxygen, and the nitrogen and oxygen combine and form, well, a mixture, but nitrogen oxide, which is NO, and nitrogen dioxide, which is NO2. So those two are, and NO2 is the main pollutant.
Okay. Yeah, because
we know it's important for your watchers to understand how we know things are polluted. We take measurements. Who's we? Well, it's governments. Governments all over the world measure air pollution in the atmosphere, and they measure it in many ways. One of the big sources of data for this particular question is satellite analysis. Satellites shoot beams of light down to Earth, and the beams of light get scattered back, and they measure effectively the color of the beam and changes in the color as it comes back to the satellite, and from that you can calculate nitrogen dioxide. The other way of doing that kind of measurement is to actually have instruments located near Earth's surface, which will then determine the nitrogen dioxide. And we've been starting to work on data from Vancouver, particularly data measured at traffic dense locations, right downtown Vancouver, and also busy intersections like Clark and Hastings, things like that. And those locations are dominated by emissions from traffic. And we find that if we compare March of 2020 with March of 2019, there's a notable reduction in air pollution caused by this medically induced coma of our society. So, I
That
mean,
must,
the COVID crisis is a disaster in human terms with morbidity and mortality. It's a disaster in financial terms because people are no longer shopping, people are no longer working. So let's not make light of that. It's a disaster, but there are some good things that have happened. That's CO2 is reduced and air pollution is notably reduced. CO2, well, the transportation sector is the major global source of CO2, cars, trucks, trains, airplanes, and those are dramatically reduced. It's unclear yet exactly what fraction of carbon dioxide reduction has occurred. I've seen anything from 5% to 40%.
and in terms of, it seems, as you said, everything's shut down, and we're seeing the results of that, and who knows if they're temporary or long-term, but I think something that struck me interesting here is from a science perspective, this must be a very clear, almost elegant illustration that something that you must have known all along is that these pollutants are caused by these things. And there must have been some contrarians saying, oh, that's just stuff in the air. But now you can clearly see, no, this was man-made.
Yeah, I mean, chemically the signature is so clear. There may be a lunatic fringe who deny its existence, very few. There are many who deny its importance. Those are pretty darn few as well. We know that there are thousands of premature deaths caused by air pollutants.
Okay.
And we know the consequences of global warming. The interesting thing is that this is an involuntary experiment. We were forced into this thing.
Yeah.
I would say the environmental scientists have a responsibility to examine this experiment, to look at the consequences of the shutdown, to understand what level of improvement has come about as a result of the reduction in economic activity, and to try and understand what we need to do in the future to improve air quality and to reduce the global warming, to back them off. And it is clear to anybody who thinks for more than 5 minutes about this, to have the economy shut down at this level is unsustainable.
Yeah.
That would be a disaster. We cannot do that. But we can shift our economy so that we no longer have such a powerful reliance on fossil fuels, relying on more sustainable, non-carbon based energy sources. And this shutdown, the experiment, will tell us what percentage shift we need to do in order to make improvements. And the reason it's important to know that is that there are going to be societal adjustments in industry, adjustments in how we use energy, adjustments in how we move around the world. And if the change towards an improved world, less greenhouse gas emission, less air pollution, if that change is driven, as it can only be driven by a combination of government initiatives and industrial development, seeking to make new products, new sources of energy, then the populace needs to buy into what is happening, because the populace will have to change the way it operates. And it'll be terrible to lose the game because people change and nothing happens. So this experiment, if I can call it that, will be a chance to say, okay, there's so much change, how much improvement are we going to see? And yes, that was what we predicted. Now this is where we need to get to a point where we want to be in terms of improved air quality and reduced greenhouse gas emissions.
And in terms of this so-called experiment, depending on how long it carries on for, do you think that it could be the case that we could observe results, or?
Interesting. We will clearly see the results of air pollution. Air pollution is a short-term thing. Yeah. The truck goes by, it emits NO2, the NO2 gets absorbed into your lungs, and then that isn't absorbed eventually is chemically transformed and disappears, rains to the earth as nitrates, as absorbed or wherever it does chemically. Greenhouse gas is a whole different scene. So the lifetime, if you want, of an air pollutant like NO2 is hours to days.
And that's what you see in LA when you look out over the view, and you can't see, and that's all NO2 in the air.
Yeah, exactly. And it has a brownish color. Yeah. but the lifetime of carbon dioxide in the atmosphere is up to 100 years. Some people say even 700 years, depending on the exact chemistry. It's a long-lived substance. So this reduction in CO2 emission is not going to improve global warming.
Right.
Yeah, we may see a minor change in the total CO2 in the atmosphere, but it has now been shown very clearly that the amount of global warming is directly related to the accumulated total over all the past emissions of greenhouse gases. So a 5% or maybe even 40% reduction for a year, it might slow it down a little bit, but not a lot. We're going to have to go backwards in terms of greenhouse gas content of the atmosphere.
It's like a blip on the chart, so to speak. Or
it'd be a small blip on the chart. And then, of course, there are global measurements of background carbon dioxide. We know what they are. They're somewhere around 420 parts per million at the moment. Those measurements continue to rise as we emit more, and it accumulates in the atmosphere. And it accumulates in the oceans as well. Carbon dioxide dissolves in the oceans and acidifies the oceans and bleaches coral and destroys any shells based on carbonate.
So that sounds like the bigger problem, and that's not something we can look at a little map and get an instant.
No, it's a bigger problem. It's a much more difficult problem. It's difficult because it's abstract. It's difficult because it's global, not local. It's a really difficult problem, and it requires a population that really understands the problem and accepts it and accepts the consequences of continued emission and wants to move back to an improved global environment. And it is a global environmental question, not a local question at all.
And they both originate from the same activities?
Yeah, they're both tied to the combustion of fossil fuels. It's very simple. And the combustion of fossil fuels is tied to the way our society uses energy.
Yeah.
And if we want to continue a society as rich and complex and varied as the one we presently have, we're going to have to find a different source of energy. I mean, we in BC are extraordinarily lucky. 95% or thereabouts of our electricity comes from hydroelectric sources. So we're okay, but the rest of the world is not.
What I wonder when I see those maps and it seems so concentrated is I'm thinking it's mostly cars and stuff more than, or is it just everything? Is it?
No, it is largely, motor vehicle. It's transportation sources, as they're called.
Yeah.
Cars, trucks, and then secondarily, particularly in China, energy is produced by burning coal and oil, and there's some hydroelectric as well. But a lot of that is coal and oil. And of course, you put your coal-fired or oil-fired power plant near the population that needs it so that you reduce the loss of energy along the transmission lines. Right. And so the emissions from power generation get all mixed up with emissions from transportation sources. It's hard to untangle the two. But if you look at a map, you can see big highways, you can see big dense populations. Those are very clear. Yeah.
I guess there's this sort of inherent conflict that this has brought about, which is productivity tied to this unhealthy production of these gases? But what you're proposing, there's alternatives and there's better ways to do things and still kind of function as regular, but it just makes you think, is there a better way? I guess.
We have yet to figure out how to exist without energy. We use an enormous amount of energy. I mean, the first thing is that we use energy wastefully, and we certainly could improve that a lot. But there's still a large amount of energy, even when we've improved the efficiency. A lot of different sources, and we really do have to move towards alternate sources of energy that are not entirely based on burning fossil fuels. That's very clear to me. You know, the other wild card in all of this is the global population. The people equals energy, and the higher the level of sophistication of a society, the more complex a society, the more energy we use. And of course, all the developing world is now wanting to live like we do with our huge energy hogs and behavior. So that's a concern. But there's another interesting thing coming, and that is, what is the global population doing? You know, we're at what, 7 billion now? How much longer are we going to continue to grow? There are people who believe that world population will reach a maximum in a matter of 2 decades, 30s or 40s at latest, and thereafter will begin to decline. So if we have a declining world population, this whole idea of continual economic growth makes no sense at all, unless everybody's standard of living goes up and up and up while the population goes down and down and down. And that's unlikely to happen. So as the world population declines, so will our use of energy, and all of these problems will start declining and becoming easier to deal with. Yeah. But there's a bigger problem tied to that. Every nation in the world has built into the DNA of its economy the idea of growth. What is the GDP growth? And with a declining population, we can't do that. Our economists have to figure out how to deal with a declining population, in other words, a contracting economy. And I don't know if anybody, I am not an economist, but I find that all rather mysterious. But it's clear to me that we do have to figure out how to deal with a declining population. So there's a number of reasons why people believe world population will decline. But the simplest reason is that in every country where the education of women has increased, where the level of liberation of women has increased, where women have been more deeply engaged in the society in terms of jobs, in terms of freedoms, every one of those societies has seen a decline in population. And the decline in population is very clear. It's signaled by a reproduction rate of less than 2 people per couple, less than 2 per woman. You know, in Canada, it's 1.7. In some European countries, it's 1.3 per woman. So there's the signal. As the developed world catches up with as the developing world catches up with the developed world in terms of women's status, so the population is going to slow down and begin to decline.
Interesting.
Yeah, these are big questions.
That is a big problem about how to deal with almost be content with what you have and not need the ultimate national growth all the time. But I think on a personal level, a lot of people are dealing with declining productivity, or what did you call it? So maybe some solutions will come up.
You know, there's another interesting thing, Bryant, and that is that, you know, I had to self-isolate for 14 days, and now I'm on very careful social or physical distancing, or whatever you want to call it. Yeah. Hey, and I've discovered how to take things slowly. There's no need to multitask. I just do my jobs one at a time, because I got lots of time. Hey, and I'm enjoying those jobs. I'm enjoying not rushing from one to the other. I'm enjoying more free time. Now, I'm privileged, I can do that. But it certainly has changed the way I view the crazy pace of life.
Yeah, likewise. It's been, I've definitely caught myself in stopping to smell the roses, so to speak.
You took the words right out of my mouth. Stop and smell the roses.
And mixed with a little bit of, you know, there's a lot of thoughts. I haven't really sat down and got into reading in the way that you normally would when things are slow, but there has been, I know what you mean. And you see it in everybody kind of settling and taking things as they come, and day by day, moment by moment.
Now that I'm allowed to get out of the house, I take little walks for exercise, gentle exercise, step across the road when somebody else comes my way.
Yeah.
Pretty easy and kind of nice.
Yeah. It is something nice about how quiet it is out there. Also unnerving, because it's like all this infrastructure, and you know that it couldn't really exist with a village population, but it seems like that right now.
No, and there are people who are suffering underneath this, suffering financially, let alone suffering from health problems, and that's a great concern. And maybe we've got to change the way we structure our society. There are very interesting, with the federal government financial support nowadays, it really makes us think much more carefully about a basic minimum income provided by the state and what that might look like, and how that might work. So there's that interesting question as well. All kinds of new ways of viewing the world that are coming from this strange experiment that's been conducted on us.
Strange experiment is spurring a lot of thought, and redesigning perhaps is the ultimate end.
Yeah, and I'm quite disturbed when I hear people say, "Oh, when we get back to the way we always were, back to normal." I think we should reconsider precisely what normal is and what we really would like normal to be.
Yeah, I think that's interesting. I've heard a lot of people have said, "I can't wait till things are back to normal." And you mentioned that we shouldn't really go back to 100% how we were. We should be thoughtful about it.
Yeah.
And, take the good lessons, take the bad ones from this, and adapt to them.
Yeah, precisely.
When from an environmental standpoint, has there been anything that's surprised you, data or stuff that you've seen that's not so obvious?
Not really. Everything was predictable.
Yeah.
The level of improvement of air quality and the degree of reduction in CO2 emissions is still yet to be seen clearly.
Right.
There are analyses going on all over the world about the air quality improvements, and I'm sure the greenhouse gas emissions people will be looking really carefully to see exactly what does happen. And there are statistical models for the amount of greenhouse gas emitted based on kilometers traveled by cars and emission rates and so on. And then of course there's the measurements globally of greenhouse gases, and we have yet to see how much of an effect the slowdown has on those measurements. But all of this will be very interesting to see, but no real surprise in my mind anyhow.
Yeah. Another thing I just wondered out of curiosity, but everyone's speaking about how small this virus is in its physical sense, and I was curious, when you talk about that air pollution, is it in a particular, its particular matter? Is it on bigger or smaller or on scale with this stuff?
Okay, and I'm not a virologist, so I talk as an atmospheric scientist. So the NO2, for instance, the molecule is very, very small. It's a chemical molecule.
Yeah.
A billionth of a meter.
Right.
The virus is much, much bigger than that. It is a very large molecule that contains DNA and protein. So it's many thousands of times bigger than that. Got a molecule. And the viruses themselves can be airborne and are, but usually the viruses are transmitted, as I understand it,
surface,
from person to person in very small droplets of moisture, which we exhale through sneezing or coughing or even very hard breathing. So the viruses would be about 1 million, the droplets which contain the virus would be about 1 millionth of a meter.
Okay.
Somewhere around there, or maybe 5 millionths of a meter, something like that.
So they're not related in that, they're not floating around in the pollution, and no, these are completely.
So when you sneeze, the air exits your mouth at a great speed, and it contains lots of droplets. Those droplets will be mixed with the air pollution. Any droplet bigger than about 5, maybe 10 millionths of a meter will settle out under gravity. Droplets around 1 millionth of a meter or smaller will stay suspended in the air. The water vapor will evaporate depending on the ambient moisture in the air around you. the water vapor will evaporate off the droplet and will leave in the air the viruses and whatever else was, whatever salts were in that droplet. And then the question is the virus viable in a dry state, or is the virus only viable in a moist state? I don't know the answer to that. A virologist will, and different viruses have different behaviors.
Yeah.
So no, viruses are from this disease, as I understand it, are spread, 1 meter to 10 meters from human beings. And they talk about social distancing, physical distancing of 2 meters. I think that's somewhat simplistic. It's probably at a first shot, a safe distance.
Yeah.
If you're standing downwind of someone, it's going to be greater than 2 meters. If you're standing upwind of someone who's exhaling the virus, it's going to be shorter than 2 meters. If there's someone running in front of you sneezing and you running behind them, that could be many meters of air in which they leave their plume of virus. It's not as simple as 2 meters only. That's a useful guideline, clearly a useful guideline. I'm pretty careful, but then I'm an atmospheric scientist. I'm always aware of the wind and the wind direction. So I always think, where's this person in relation to the wind, and where am I standing? If I'm standing upwind, I'm okay. If I'm standing crosswind, not so bad. Downwind, I got to be careful.
Yeah, I'm holding my breath in the elevator, so I don't think you can be too careful. And
in enclosed spaces, I would do that too.
It's a good guideline, but I think there's a lot that we know, but there's probably a lot we don't know still too. And
yes, clearly we're still discovering lots about this virus.
I read one account. It was a lawyer went into the office on a Friday, went home. His secretary went in on a Sunday, something like that, and they passed it to each other. So
yeah,
there was 2 meters between them.
Yes.
Anyways, that's really quite fascinating to hear from you, and I really appreciate your time.
Good to talk to you, Brian. Good fun.
Yes, take care.
Lots of interesting questions. Thanks, Brian. Bye.